Hello, Algebra 2. Today we have an introduction to parent functions. Now, you should have just got done graphing 4 parent functions and filling out a table of values for them. And it should be these 4 parent functions that I have on the screen here: linear, quadratic, cubic, and square root. And I have their function rules over here. Linear, f of x is equal to x. Quadratic, f of x is x equal to x squared. Cubic, x cubed, and oddly enough, square root parent function is the square root of x. So now, your next page, wherever it should be at, should look like this. And we are going to identify parent functions for g of x from its function rule. Then we're going to graph g of x on a calculator and describe the transformations. And I know you guys don't have a calculator, but we're going to improvise. So the first thing we need to do is find out what the parent function is for each of these. So let's look at the first one here. G of x is equal to x squared minus 3. All we have to do is we look at our exponent here. So x squared, go back up here. X squared, simple as that. So we know that this one has a quadratic parent function. Let's cover all our parent functions first here. So this one, g of x is equal to x minus 3 squared. Now, these look oddly similar, and we will be able to see the difference between these in a minute here. So, x minus 3 squared, again, just look at our exponent. So that is a quadratic parent function as well. We'll scroll down to this last one here. The transformed function, g of x is equal to 3 times the square root of x. Our parent function, square root. So the next thing we need to do is describe the transformations. We need to graph it in order to do that. So if you guys, I hope that all of you have our class webpage bookmarked by now, and if you don't, probably should do that. So the other day in class, when we were looking at this, I showed you the classroom links I have here. We have Desmos and GeoGebra, and they are both very good graphing tools. And we'll use both of them today in the lesson, just so you guys kind of get a feel for them. So first we're going to click on Desmos. And yours should pop up something like this. And it's very simple. So all you got to do is x squared minus 3 for the first one. Okay, there's your graph. And then you can turn your graph on and off over here. But I put all the values in here already, actually, so I'm going to use this one. So x squared minus 3. And then I'm going to put the parent function on there as well. So you can see how they change. This orange one, that's the parent function there. And this is our transformed one. So what transformation is happening here? That's all. And that's all we need to find out. And it's a vertical translation, yeah. Down 3 units, so vertical shift down 3 units. Then let's see. And so, you guys are going to need to graph that over here. You have to graph the parent function and g of x. And if you guys read that in the directions, said use 2 different colors for the graphs and label your graphs. I want you guys to use 2 different colors, like for now, when all this is fairly new yet, because it really, helps you see the difference between the graphs when they're both on the same coordinate plane. Let's graph this one here. G of x, x minus 3 squared. I'm going to have it right here. See, x minus 3 squared. So, and the orange one is still our parent function. This one is being translated right 3 units. So it makes a difference if it's in the parentheses or not. As you can see, this, if it's outside of the parentheses, that vertical, and inside the parentheses makes it a horizontal shift. So in your notes, I'm going to scroll down. You guys should have their quadratic parent functions and describe their transformations. And then you guys are going to need to graph these. And I cheated and I used the graphs we just did. But, and then so our last one is 3 times the square root of x. I'm going to graph my parent function here, and then I'm going to graph my transformed function, 3 times the square root of x. And so what is happening here? If you look at the key points here, like 1, 1, or 4, 2, it's getting bigger. Like this one is at 4, 6, when it should be at 4, 2, and this one's at 1, 3, should be at 1, 1. So it's being stretched from the x-axis here, as you can see, and it's a vertical stretch by a factor of 3, because this is originally at 1, 1, and now it's at 1, 3, so 1 times 3. And then you need to graph that one as well. So you guys can go ahead and try the next 3 functions on your own, and then we'll have another video.